Welcome, students. In the next few minutes, we're going to absolutely master the periodic table. This isn't just for your board exams. It's about understanding the very building blocks of the world. Let's get started.
So, let's start with a puzzle that scientists faced for centuries. You've got 118 known elements. Some are metals, some are gases, some are super reactive. How in the world would you even begin to organize all of them to make some sense of it all?
Well, the first attempts were kind of like rough sketches. You had Dubber Rayner, who saw that some elements came in groups of 3, like little families. Then came Newlands, who noticed a pattern that repeated every 8th element, sort of like a musical scale. But the real game changer was Dmitri Mendeleev. He arranged the elements by atomic mass, and, get this, he was so confident he left gaps for elements that hadn't even been discovered yet. Ready to ace this chapter? Here's our roadmap. We're going to see how we went from those early ideas to the modern table we use today. Then we'll decode the trends, tackle a real exam-style question, and finish with a quick knowledge check. Let's do it. So, Mendeleev's table was brilliant, but it wasn't perfect. It had a few little quirks. To fix them, scientists needed to make one big shift in their thinking, a shift from an element's mass to something even more fundamental. See, Mendeleev's big idea was that properties repeated based on atomic mass. But this led to a few headaches. For instance, if you look at cobalt and nickel, their masses are almost the same, but their positions didn't quite line up with their properties. It was a clue that mass wasn't the whole story. Okay, let's jump to the most crucial part for your exam, the modern periodic table. This is it. This isn't just some chart. Think of it as your map to the elements. And here it is, the aha moment. The modern periodic law is based not on atomic mass, but on atomic number. That's the number of protons. This one change fixed all the problems in Mendeleev's table and gave us the perfect, accurate map we use today. This is a star-marked concept for sure.
So let's get the lay of the land. The 7 horizontal rows, we call those periods. The 18 vertical columns are groups. And elements in the same group are like family. They have similar chemical properties. Then you've got your blocks, S, P, D, and F, and that very important zigzag line that separates the metals on the left from the nonmetals on the right.
Now that we have our map, let's learn the rules that govern this world. These periodic trends are pretty much guaranteed exam questions, so let's really dive in and understand them. First up is valency. This is just a fancy word for an element's combining power. How does it bond with other elements? And the key to figuring that out is looking at its valence electrons. Those are the electrons in the outermost shell. Next, we have atomic radius. Again, sounds complicated, but it's not. It's just the size of the atom, the distance from the center, the nucleus, to the outermost electrons. That's it. Okay, this slide right here is your secret weapon for the exam. This is a perfect summary for revision. Go ahead and screenshot this. It's your key to solving any trend-based question they throw at you. Notice how valency changes across a period, but stays the same down a group. See how the atom size actually shrinks as you go left to right? These patterns are everything. All right, we've got the map, we've got the rules. Now let's see how this all comes together to solve an actual exam question. This is where we apply what we've learned. So you might see a question that looks something like this on your exam paper. At first glance, it might seem tricky, but trust me, once you know the steps, it's pretty straightforward.
Okay, so here's our question. An element has an electron configuration of 2, 8, 2. Don't panic. All the clues we need are right there. Let's just break it down methodically.
This step-by-step method will never fail you. Step 1, find the atomic number. Just add up the electrons. 2 plus 8 plus 2 is 12. Done. Step 2, find the period. How many shells do we have? 3. So it's in period 3. Step 3, find the group. Just look at the valence electrons, the last number. It's 2, so it's in group 2. And with that, we know the element with atomic number 12 is magnesium. See? Easy. All right, time for a quick fire round to really lock in these concepts. Let's give our brains a final power boost. Get ready to answer some why questions, just like the ones in the Use Your Brain Power sections of your textbook. These are all about making sure you really understand the concepts. Okay, first one, think about this. As you move across a period from left to right, why does the size of the atom actually get smaller? What's going on inside that nucleus?
Then there's your answer. As you move across the period, you're adding more protons to the nucleus. That means the positive charge gets stronger, and it pulls all the negative electron shells in just a little bit closer. It's like a stronger magnet.
Next question. Why is it that all the elements in the same group, the same column, have the same valency? What do they all have in common?
Exactly. It's because they all have the same number of electrons in their outermost shell. And since those are the electrons that determine how an element bonds, if they're the same, the valency is the same. It's that simple.
And that brings us to the end. But think about this. The periodic table isn't just a list of things we've already found. It's a predictive tool. That's why it's so powerful. So now that you know the rules, you can see why this matters. Keep asking questions and keep exploring.